I am here with the very first 5-time guest on Everything EOS. I'm here with Tal Muskal, the Michael Jordan of EOSIO developers, and the CTO of LiquidApps. What's up, Tal? How are you doing today?
Great, thanks. I love being here.
It's been just 2 months since you were on here. We did the developer spotlight on you. You went into some of your background and what you were doing before LiquidEOS and LiquidApps and blockchain and Bancor and everything you've done up until this point since entering the blockchain industry. And in those last 2 months, we at LiquidApps, we've just been rapid firing development. vCPU, which I think is going to be a very interesting topic that we're going to get into in a little bit. LiquidChess, which I think has a cool story behind it because of your chess story and Deep Blue or Deep Junior. But the topic we're here to kick this off with, and the most important to us as LiquidApps in the short term, because it's in 2 weeks, is the DAPP Network Hackathon.
It's coming up, and we're very excited about it. It's on November 17th until the 24th, and it's going to be both physical and virtual. It's a global hackathon, and we're going to have a great team of mentors there. I'm going to be one of the mentors as well, which I'm very excited about. I really had a great time being a mentor in the San Francisco EOS Hackathon. I miss those times, and I think it's going to have a similar. I hope it's going to have a similar vibe to those hackathons.
Obviously, you could have been a judge, but I think it's really cool that you're going to basically be the lead mentor. You're going to basically get away from your terminal for a week to help with other people's terminals and just be fully available to everyone participating in this hackathon. Like you said, the best part about it for me is that it will be local in Tel Aviv. I will be in Tel Aviv. I'm looking forward to that. But the global virtual aspect of it is something that's never been done before within the EOSIO community. And it's just a great opportunity for the people who weren't able to make it to any of the hackathons last year. What was your motivation for wanting to organize the hackathon?
The major goal for the hackathon is attracting developers, having more people getting their hands wet with the technology, seeing what the state of it is, and giving people more confidence on the maturity of the technology and how it can be used.
That's what has me excited is our technical team your whole team have just worked so hard to get these services released and get them to a state that's usable. And now it's like they're ready for showtime. We want to see what they could do because DAPP Network, LiquidApps, the tools we're building for the DAPP Network, it's like an extension of EOSIO. It makes it more powerful. I explain it to people. It's like putting EOSIO on steroids. And we have all of these talented developers that, especially lately with the resource constrictions, let's just jump into that. I know it's later in my plan of topics I wanted to go over with you, but let's just jump into it. The vCPU, because I think this is super relevant. The network has basically been congested to almost a standstill over the last 2 days. And because of the mechanism that's causing this network spam, and I call it spam, but to someone else, it's not spam. Someone else is mining tokens.
It's actually even more than that. CPU is on a blockchain is a very, very scarce resource. We have a single thread of computation. It's the equivalent of one CPU that's everyone's sharing. We should expect it to be fully utilized. It's not supposed to system. That's supposed to be the steady state if this thing is successful. We should expect no idle time, and that this CPU resource should be fully utilized. Having said that, we can now think of think of utilizing things like vCPU to offload most of the intensive computation to other means and other more horizontally scalable means. as I see it, the CPU of the mainnet should mostly be used for provisioning purposes and for syncing other types of resources, because it requires a complete consensus and a replication of the entire state, of a replication of everything. So we shouldn't expect it as a method to scale well without those kind of extensions.
So you're saying like what's happened, like when DexRan was doing his stress testing, and now this new stress testing, what is it? Everyone EIDOS? Is that what it is?
I think. Yeah.
So now that this is running and it's a 15-month like token generation mining event, so it's not going to stop. Like the 1000x multiplier on the mainnet is done, and it was something Dan proposed about a month ago. So this kind of forced everyone's hand. We are now in a state on the mainnet where there's not going to be any more free lunch. But that doesn't mean that applications, decentralized applications on EOSIO, or EOS in particular in this case, need to be limited in what you can and can't do on chain. And you want to kind of get into, since vCPU is ready to be used and we have this hackathon coming up, let's give some ideas to people brainstorming of how they could utilize vCPU. And why don't we introduce what vCPU is first, and then we'll get into some of the potential use cases.
So vCPU is a way for a contract to run in kind of threads, where the DSP runs the code of the contract, and then on the chain itself you can validate the consensus, or validate and compare the results, and even build your own kind of consensus. Or in cases where the computation is verifiable, an example I like to give is a sorting mechanism. Sorting is something that's very heavy to relatively heavy to compute, but it's relatively easy to verify. It's much more easy to verify that something is sorted than to actually sort it. So there are many algorithms that can be offloaded to even one DSP without really trusting it. Another example can be building a machine learning model. You could actually evaluate the score of the machine learning model, and it's much more lightweight than building the model. Building the model is much heavier than actually validating or evaluating the score of a model. So I think those kind of asymmetrical computation opportunities are part of a lot of data-intensive applications, and those things we didn't really begin even to imagine them up until now. Data-intensive applications on blockchain. It's something that less than a year ago when I discussed it, like people kind of raised their eyebrows when I tried to when I discussed things like on-chain artificial intelligence and the economics around it. So people were quite skeptical. That's one of the reasons that chess was an important showcase for me personally.
So let's just get into the first use case that we have a blog article. The link will be in the description below. But Tal built what is called LiquidChess. And it is the first application of vCPU that we released on our GitHub and our blog. So why don't you let everyone know what LiquidChess is and how it has something which is the AI that nothing has ever had before on a blockchain.
So LiquidChess is another example of an application. It's a second example or showcase of an application that's fully decentralized end-to-end, what we call Immortal application.
Could you explain, for anyone who hasn't seen the first 4 episodes of you on here, this is like Tal's thing. Like if you Google Immortal application, no one's ever trademarked this term. This is a Tal Muskal term.
I think up until now, the selling points of blockchain technologies and cryptocurrencies are the immutability and decentralization. And those 2 words, those 2 terms say nothing to most people. It's like completely gibberish to most people. Like, what does that even mean? What's decentralization mean? Isn't the internet decentralized in the first place? And like, it's very far from people. And I think Immortal resonates better in the sense that that something is there forever and nobody can touch it. And that's kind of another way to describe this, like a perfect decentralized and immutable system.
The front end that's decentralized, like when LiquidChess got released, a lot of people heard the term Immortal application for the first time. People were coming into the Telegram channel and they were like, tell me more about these Immortal applications. What are more details? This has never been done before. Like your smart contract could always have been on a blockchain, but you still need a user interface to work with, to interact with that smart contract. And that could always get taken down. You could have man-in-the-middle attacks and DNS attacks. So is this the very first time that anyone has ever done this, as far as you know?
Yes, as far as I know, at least. I think that the technologies, part of those technologies existed in other places, but as far as I know, there isn't like a full stack solution to do that, and that's why nobody really did a showcase of that kind of
so thing. Let's peel LiquidChess back like an onion, and if you're peeling an onion back, you start at the top, the front end. So what's unique about the front end of LiquidChess that as an Immortal application?
So it's completely static, like modern front ends should be, and that gives it the ability to be decentralized easily. Like it's static, so it can be served like storage, and that's why it can be stored on a decentralized file system and be served from a decentralized file system. So it keeps the access and the user interface immortal in a way.
I've been asked before about the decentralized front end. Some people get it confused with VRAM because they know VRAM with the near unlimited resources. Maybe you could have stored this front end there, but the front end's not stored in VRAM. You want to kind of explain the IPFS of it?
Sure. So in a way, LiquidStorage was a low-hanging fruit for us because having the contract access state like we do in the VRAM solution is quite hard. It's much harder than just providing the incentive model for distributing storage. You can say that VRAM already has all the parts you need to provide something like Filecoin or decentralized storage, and with LiquidStorage we make it more accessible and easier to use as a storage solution and not something that the state that the contract can need as a state. Having said that, if you store something on LiquidStorage or on IPFS, your smart contract can still read it in a trustless way if it has the hash of the content. So that's pretty useful, even if you want to do things like actually processing big amounts of data using vCPU. That's something you can do still completely decentralized and use IPFS without VRAM. Just to be able to load it on demand and not to query it like you do in a table on a contract.
All right, so there's an IPFS front end. That's what's displaying what you see on the screen here. So you see like these images of the water drips, like that's all being hosted on IPFS. So the very first thing you do on this application is you create an account. I don't need a wallet. I don't need Scatter open. All I need is a username and a password. So that is what we call LiquidAccounts. Can you kind of go into detail on what's going on underneath the hood here?
So LiquidAccounts is another service that we built on top of VRAM that allows you to interact with dApps without a native mainnet account. And the way we do it is we store the public keys associated to accounts on VRAM tables.
So to sign a transaction, though, you need a private key. So without a private key being visible to everyone on a blockchain, like how could you have the application know what the private key is to interact with the contract without the DSP themselves knowing your private key, or I guess the blockchain itself knowing your private key?
Right. So the way we do it in the demo is in the LiquidChess application is we generate a private key from the username, the password, and a salt for the application. That way, the keys can be reconstructed from those things. But the implementation itself requires a private key. The LiquidAccounts on the native level, it uses private keys and accounts as the building blocks and as the first-class citizens. So you could use Scatter to manage those keys, and you could interact with the same kind of tools, and even a hardware wallet. And another interesting thing you could do with LiquidAccounts is because you could interact based on a public key or a key pair. You could actually use Ethereum keys to manage accounts, and you don't even need to create them. You can theoretically send tokens to an Ethereum address, and whenever the Ethereum user come to that application, he can claim using his Ethereum tools, using his Ethereum private key, using his maybe even MetaMask, but to interact with the EOS application, basically. So you could theoretically airdrop to Ethereum users an EOS token.
Let's keep those theoreticals coming, because the whole point of this conversation is to drive attention and ideas for the hackathon coming up. And all of these theoreticals could actually happen. And what better motivation to do it than $50,000 in prizes from being able to work from home. So back to the LiquidChess. We keep going all over the place. There's just so much to talk about. So we got to the Liquid accounts. So you go down, you create your username and password, then you check the box, play against the computer AI. So if you see this, like we're used to like regular applications, like if I'm playing a regular web app, playing against the AI is nothing new. But this AI is different because it's actually on the blockchain. It's not off chain. Like everyone thinks that something like this needs to be off chain, and it did up until now. So how did you get an AI on a blockchain?
So it was exactly the same way I got the engine validation. So it was exactly the same way I got the move validation running on the blockchain, which was to take Stockfish, the existing chess engine, the open source one, and to compile it in WASM, basically. Then I included it in a contract and used vCPU to run the same code in all the DSPs and validate that on the original contract that the results are the same and that they're expected and they're valid.
So vCPU is being used for the chess engine and for the AI. They're two separate components.
Right. So, yeah, it's two separate components. They're compiled in the same code, in the same contract. But that's the gist of it. It allowed me to just take existing code and compile it in a contract context. And I'm sure if I run it, I'll try to run it on an actual block producer environment, it may take 5 seconds, or it may take like whole seconds. And on EOS, you're limited to 30 milliseconds per transaction, which is also quite expensive to use the whole 30 milliseconds. So in the first place, it's very hard to even do the move validation in such limited constraints. And the C++, the original optimization, the original implementation is already quite optimized. It uses things like bit boards to do tricks like bit masking numbers that represent boards. Think about it. You have 8 by 8 boards in chess, and you have 64 bits on numbers. So you can do arithmetic operations that help you represent numbers as states of the board. And if you do it efficient enough, it's mostly arithmetic and bit shifting on 64-bit numbers. So it's already quite optimized, but still the constraints of a blockchain is something that's not scalable enough to do move validations for everyone.
So if you just ran a private testnet, would you have been able to do the same implementation on just regular CPU, because it's like a local environment and you kind of have limitless resources?
It would be very hard, because I would probably have to either chunk the computation to many transactions, and it would be even more expensive, and it wouldn't be transactional. It would be something.
Well, if it was private, it wouldn't be expensive, just because it's. I'm just thinking, if it's a private blockchain, and you don't have to worry about anything else. But there's still other problems besides cost.
Yeah. I would probably need to either chunk the computation somehow, and then it wouldn't be transactional. And I would need to optimize to not just optimize, maybe even just the chunking part of taking existing code and trying to chunk it to 30 millisecond chunks of computation is not trivial. You need to understand the code that you're taking. Not like taking existing code and just throwing it in a contract.
So because of vCPU, you didn't have to modify the code much. You took, what is it called, Droidfish? Is that the engine?
Stockfish.
Stockfish, sorry.
Yeah.
So you took an existing C++ written chess engine called Stockfish, which it's very popular. I think Droidfish is a different one. And what kind of modification? So you just went to GitHub, you forked the code, downloaded the repo, and you're like, what modifications needed to be made to that before you could use it in your contract?
There were a couple of small modifications regarding, I don't even remember, like small things regarding the types that are missing in the very basic type library. Several includes that are missing in a WASM environment. File system things.
So small
system access, very small things.
Yeah. So I think this is such an important thing to highlight about what you can now do, because you were like, the whole point of DAPP Network is that things that are redundant and being built over and over again by different teams, like they shouldn't have to do that. Build whatever you're trying to do with your application. You shouldn't have to build these foundation layers to your application. And the chess engine is a very foundation layer to your application. If you had to write that yourself, that would have been a full-time job for weeks, probably. I don't know how long.
I have a couple of references. I think we have a couple of examples for very good people in the community that are working on this existing challenge. And it's not hard. It's you could say that I cheated in a way.
You hacked the system, Tal, and I hack the system is actually a good word, a good way to kind of bring up that we keep talking about the 30 millisecond limit of transactions or computation. Is it what's the exact
transaction?
30 millisecond limit of like if basically if a transaction hangs for longer than 30 seconds, it like cancels it, or
it just aborts. Yeah,
it aborts. So that means if you have to do anything that's more computation intensive than you can accomplish in 30 milliseconds, the transaction is going to fail and get aborted.
Sure.
So how did you hack that out of the system? Like that is like built into the system. You shouldn't be able to break that, but you got around it.
Right.
And when I say break, I mean you made it better.
Yeah. So the reason we're not limited to the 30 millisecond limitation anymore is because we now run the vCPU aspect of the execution on the DSP process, which is not even a Node OS process. It's hosted on the same processes as the DSP services, and it has the limitations that we give it, essentially. Whether it's access limitations or memory limitations or computation resources. So it's the same contract, the same WASM contract, but it's running on DSP, tricked to think it's running on an actual node, an actual EOS node. It has all the interfaces that the EOS node exposes, but it's implemented completely differently to allow it to still perform the logic, but not require running it on an actual EOS node. We could hack EOS, the EOS node to allow simulation of things that are bigger than 30 milliseconds, but one of the things that taking the hosting environment from the node for the simulation part actually gives us some very interesting potential capabilities, like exposing GPU interface to that contract execution. Whatever is running on vCPU can actually utilize GPU acceleration now. We can expose things that were not originally exposed to a block producer node.
So not only are you able to have horizontal scalability that you can't have on vanilla EOSIO, but down at some point you could swap out that CPU for GPUs, and you could basically outsource your processing to a GPU, which block producers don't even have. So you're able to like run things faster than it's possible.
Right. You could say that specific DSPs have vCPU extension that supports GPU, for example, and only them can run specific offloaded computations. And then we can really start see some interesting machine learning and deep learning applications and data crunching applications that are actually distributed.
When you say that we could have these machine learning and these AIs now, I don't think we have an implementation of the GPUs yet, but let's say that hypothetically the day comes and this might exist.
Yeah, the code is open, so that's another thing that people can think of exploring.
And the links will be in the description, obviously, and at the Hacker Earth link also. Earlier, you brought up how it used an open source C++ chess library. Mm-hmm. There's plenty of machine learning libraries and AI libraries that already exist.
Right.
So you're saying that
Torch, yeah,
these libraries could be actually put onto like EOSIO through the DAPP network, and you could be running with very little modifications here and there. You could be running these battle-tested machine learning like engines essentially on a blockchain.
Yeah, you could even have incentivized competitions between specialized DSPs that can train, each one can train a different model and then just evaluate them on chain and have a winner for, like, have a prize for whoever builds the best model. And that, for me, that's one of the reasons I got into blockchain, because I come from an AI background, is to allow this kind of collaborative incentive models to build machine learning models and to advance the field. Because right now there's a race between the big companies, the Googles and the Facebooks of the world that have so much data. They're like the corporates of the world in terms of how efficient they are.
They're corporations with this more power than sovereign nations.
Yeah.
It's insane.
And they're going to be more powerful because centralization is good when you're building like a superior AI. Then being centralized and being a monopoly is a good thing, because that's the only way you can get like the scale of data that you need to actually train a deep learning model. Training a deep learning model requires not a trivial amount of data, something that usually startups don't have. Mm-hmm. Especially a unique mesh scale data set. Even if you got your hand on a huge data set, it's probably a free one and open, and then everyone else can use it, even the big corporates. And now with the ability to incentivize learning in different, like also horizontally, and being able to incentivize whoever builds the best model, like we see, there are platforms that try to do that. But I think bringing that to blockchain is something that can give us a fighting chance against those monopolies.
When you brought up the big data set, what bigger data set is there though than a blockchain? Like you could
social graph is an important data set, and it's and there's a huge data set of images that Google has and Facebook has. A lot of tagged data set as well. A learning set is usually labeled, and for years we've been working and labeling those data sets for those companies, for those corporates, till we move those applications to be open and decentralized. We won't have the data even on the blockchain. So that's a critical part for it, and actually it's another reason for us as users to care. Right now we don't see the implications of that. We just see the inconveniences of big corporations controlling our data, like that they're able to delete it or monetize on it. I think the next step in that path is much more dangerous, and then it may be too late if we only start caring about owning our data once we see those kind of implications. That's one of the reasons I care about that.
When you, Tal Muskal, when you say own your data, and we're talking about like the future of technology, what does it look like from like how do you own your data where you actually own it, no one else has access to it?
So there are two types of data that I see in the future. There's private data and public data. There's transparent data and private data. There are many ways to do decentralized logic on private data. Most of them involve things like zero knowledge, and there's public data. And public data can and should be transparent and should be accessible in the same way for everyone. right now, even all the public data of Facebook is not something that you can easily access and process as a researcher.
Well, they could limit you too. I mean, they could limit your API calls, for example, and say,
yeah.
okay, you
and
limit
even
me
the
like
fact
you're doing.
and even the fact that you need to perform an API call is not reasonable in the context of building a deep learning algorithm. Like imagine the bandwidth that you need to just pull all the data. You need it local. That's what I'm saying.
The machine learning algorithms and the AIs, how advanced could you get with that before someone decides to build something that extends into a vGPU or whatever they might call it if they want to build it? Like, if you don't have that computation power today, because the hackathon's in 2 weeks, I don't think that'll be built yet by anyone. Maybe unless some DSP has been working behind the scenes, we don't know.
I think bigger things have been done in shorter times.
I mean, you did build LiquidChess in, I think, less than a week, and that's while fulfilling all of your other responsibilities.
To be honest, it took 2 days to build the entire game. I told Benny, write Tal ? On Twitter, and we'll go from there. That way, they don't have to do it.
So if you built LiquidChess in 2 days, the hackathon's over a week. I think it's from a Sunday to a Sunday. So in like 9 or 10 days, like the possibilities are endless.
I don't want to say it in the context of the hackathon, but you can start thinking of porting existing applications, basically taking existing open source projects and porting them to be decentralized. Do you remember that in our first interview, the one that was 3 parts, you guys asked me what I envision happening in 5 years in terms of compatibility and in terms of like how easy it will be to develop. And it was the first time I actually thought about it. It was during the interview, like in this perspective of like what do I see in 5 years. And you remember what was the answer? To take existing code and to be able to run it on the blockchain without really knowing all the complications. So I'm happy to say that now with vCPU, I feel that we kind of achieved a big portion of that vision.
Are you saying it's not 5 years out now? It's less than 5 years out.
Yeah, and imagine when we have JavaScript compilers and things like that, JavaScript compilers for WASM, then it will really be close to that, to be able to take anything and port it to blockchain technology and to make it decentralized. So I think JavaScript to WASM compiling will open the potential audience of people writing decentralized applications. This with vCPU and removing the limitations can actually allow any kind of developer to write blockchain decentralized applications without really knowing anything about cryptography or without knowing anything about the underlying magic that happens.
And that's just crazy to me, because the same way you said that you could take a C++ library, an open source library that does everything you need it to, and you could just import it into your contract. There's hundreds of thousands of JavaScript libraries out there that might be useful with all of the logic already built out. So you're saying if this compiler could be built, that it'd be super, super easy for anyone to import any existing JavaScript library into a contract in the same way that you brought in the Stockfish engine into your LiquidChess.
Yeah, and I think that's not very far for the original vision we discussed in our first interview. So
we had some really big news come out today, which I hope is today, because we're going to do some magic here. If it's not today, this video will come out whatever day that today was, whatever. Interoperability has been a theme of the message we've been trying to convey as LiquidApps, a multi-chain vision, so to speak. And as of a couple hours ago, we now have the ability to use LiquidX. Why don't you just introduce it here in case anyone hasn't read the blog article yet?
Sure. So LiquidX is actually not an service. It's not a DSP service, but more of a feature or a platform support in the entire network and the DSP software itself. And LiquidX allows you to run DSP services on other chains, on sister chains, on any type of chain. And it's doing that by providing the same services on the sister chain, while preserving all the DAPP tokenomics and the provisioning model on the EOS mainnet.
So let's get into the implications of this. This whole conversation was kind of built around the hackathon. What does LiquidX mean for the LiquidApps DAPP Network Hackathon?
I think it becomes much more interesting to a much bigger audience of the EOSIO community. We have some tribalism even inside the EOS community. We have maximalism even inside our own small community, and I hope this will help to really bridge that and to amplify all the great advantages that there are in all those different sister chains. So there are no longer experiments for a public chain or an application-specific chain. I think that will help those systems to take those amazing innovations that they did as developers and as communities and actually bring back that value to the entire community. That's what gets me excited about it. And of course, it means that the hackathon should be much more appealing now to a much bigger audience.
So that means if you kind of maybe got turned off by the mainnet and you move to a chain like Talos, for example, or Bose or Wax, now all of these DSP services that were previously only available from EOS mainnet applications, now you could still have your Talos application, but you're able to take advantage of all the other things. Let me backtrack, because a lot of times when we discuss these services, when we're talking about it on the mainnet, we're talking about saving on resource costs. But on other chains, the resource costs aren't nearly the same. So there still is a savings on resource costs if you use something like VRAM, but it's maybe not as critical. But there's other aspects of VRAM besides cost that is going to be game changing for these sister chains. Could you kind of just highlight maybe some of the things that VRAM allows for an application besides just saving money on resources?
Because VRAM can also be served as a shared memory solution, and because the IPFS serves as the backend for all those chains in LiquidX, you could essentially pass one pointer from one chain to another to copy the entire data set of an application. Let's say you want to move your entire data set and application to Telos from the mainnet because it became too expensive. You could essentially pass one pointer from your mainnet contract to the Telos contract and read the table as if it was built on Telos, as if the table was hosted on Telos. Because it's the same DSP that's serving the memory for both chains. So you can actually do interesting things. You can aggregate a queue of messages on one chain and dispatch it once a minute with LiquidScheduler, and then process it on the other chain, and kind of have infinite bandwidth between the chains, which you can do almost anything with. You can spin up your own chain for things that you trust only yourself, and you know that your users only trust you. You basically get the full spectrum of decentralization and centralization and efficiency to build your own custom needs for.
I want to get into one more thing before we end this, but let's close out the hackathon here. So the hackathon's open to anybody in the world that include and any blockchain really, but especially with LiquidX, any EOSIO chain, and then Ethereum, more than welcome to join. I thought we talked about this the other day and we were half joking, but this hackathon's different than the EOS hackathons last year. The EOS hackathons last year were sponsored, managed, organized by Block.One. The DAPP Hackathon is managed, sponsored, operated by LiquidApps with no affiliation to Block.One.
Yeah, I think that's a good point. That's a hackathon that's not sponsored and not affiliated with Block.One. I think it's a nice and a great opportunity for the people from Block.One to actually participate. And I know that if I were them, I would love to participate in our own hackathons, and I know they didn't have the opportunity until now. Not just to not just to show how good they are, but to actually build things in public that aren't related to their main day job, but still in the technology that they help build. I think it's a huge opportunity, and I would love to see Block.One employees participate as well.
Hopefully Block.One will just give their employees their blessing, I guess. I don't know if they'll outright say it, but I would love for Block.One employees to participate in this hackathon. I'm not just talking about Dan Larimer. Obviously, if Dan wanted to, we would let him participate in whatever way he wanted to. But I'm just thinking like anyone there, anyone that's working with this code base.
Same goes for mentorship, by the way. I invite everyone who's a superstar in the community to try to be a mentor, and many of the very strong technical people are in Block.One. So obviously I would love to see Block.One people as mentors.
Really hope it happens because I think once they dig into DAPP Network tools more, they're going to understand the power that it unlocks. And I hope that they end up having the same respect for the tools that you've built as the respect that you have for the tools that they built and are currently still building. And that drives us into like the final topic I want to hit on, and that's just EOSIO in general. So back at B1 June, EOSIO 2.0 was announced along with EOS VM, WebAuthn, a lot of other tools and improvements. But it was just very recently, a couple weeks ago, that they actually released the code base for EOSIO 2.0. It's still a release candidate. But I just wanted to kind of get your thoughts on it, about some of these improvements that are coming with it.
There are a few features that are only released now, which is the YubiKey encryption support, like authentication support. I know they're deprecating deferred transactions, which was kind of problematic in many ways.
Isn't there there's this DSP service that you built? You know, it kind of replaces those stupid deferred transactions that caused all those problems.
Yeah, LiquidScheduler.
Yeah, so that you're kind of forward thinking on that because LiquidScheduler came out before we knew that they were going to get deprecated. So that's interesting. So that happened. They also released.
To be honest, I keep pushing them to deprecate it in every conversation that I have. Not because I want to make LiquidScheduler more more useful, but because I think it introduced so many issues back in the early days.
Like how many casinos had to get hacked because of deferred transactions?
Exactly. Yeah, yeah. It opened up so many holes that I really agree with the decision to deprecate it and rely on an external thing to handle that, external to the base layer, whether it's external as a server or a second layer solution like ours.
EOSVM was brand new for EOS 2.0.
Yeah, that's exciting. It's going to release a lot of pressure and on the mainnet. I guess I'm a little bit less excited about it just because I'm starting to get used to horizontal scalability.
That was one of the promises, wasn't it, during the EOS ICO, was this horizontal scalability, parallel processing. So I guess what you're saying is that EOSVM increases the throughput of that single thread. It's like a one-lane highway that just is the speed limit is increased on the highway.
Yeah.
But what parallel processing is, it's very important.
Yeah.
But what parallel processing does is it turns that one-lane highway into an infinite lane highway, as wide as you want to go, and that's what parallel processing is. The cars being able to go faster is just, that's cool too, but you're still limited to that one lane. And what you're saying is with vCPU you can go parallel.
Yeah, yeah.
The part of this EOSIO 2 blog release that Block.One put out that kind of got missed by a lot of people is the EOSIO Quick Start Web IDE. And as a developer, like what does this mean for someone getting up and running like quickly?
First, it's amazing. I love web IDEs. I used Cloud9 for a couple of years. And the fact that you can without installing anything, just get things started and compile a contract and test it and run it, I think it's a kind of a game changer. That was one of the barriers, like installing the SDK and everything. And
I remember at the San Fran hackathons, everyone had to install this giant Docker file, and they all of a sudden the email reminders, please download this at home because we can't have 600 people downloading this giant file at the same time. Just like blockchain aside, like setting up a device.
If you want to compile it, it takes hours. It literally takes hours to get an environment running before they organize their releases. Now it's a bit better, but still the entire environment and the testing environment and having a local chain running, I think that's it's really, really convenient. If you hadn't have a chance to look at what they released and you're an EOS developer, I encourage you to do it like right now. And we have a little thing we released around it. I think it's going to be out by the time we release that video. But it's a Zeus-based IDE, also based on Gitpod, which is the same platform that Block.One used. But you get a quick start environment to use all the DAPP services just with a click of a button without installing anything.
That's going to be invaluable, I think, for the hackathon, because I remember the EOS hackathons, like the first couple hours for some people were spent just getting set up. If they didn't prepare ahead of time or already had been a developer on EOS prior to it. So if this is a tool that's available for people in a DAPP hackathon, that's going to be huge. And it actually, Pete K didn't know that Neb was working on this. So whenever he was doing the Everything EOS developer courses, he was using like command line tools or like EOS Studio or something, and he has to actually go back and make revisions now because this cloud environment, the Quick Start IDE is just so much better that he's just going to redo courses. So hopefully, our audience that stuck with us this long, hopefully they'll go check out the Cloud IDE. It should be available. If it's not, couple hours, maybe a day. I don't know. It'll be up before the hackathon. Let's just say that.
It's actually a good point in general. I've participated in many hackathons, not just as mentor. And one of the most important thing is to come prepared, is to read in advance what you're not to try to learn both the technology stack and what you need to do for your application at the same time, because the hours are precious. So you would want to come prepared for every hackathon, and especially in terms of the actual technical environment, the tools, see that everything is working, that you can actually compile a contract before you go to an EOS hackathon, or know how to use a DAPP service before you actually come to the DAPP hackathon.
I think we should close this out with a legendary Tal story. I know there's so many legends, and you just said you've participated in many hackathons, not just as a mentor. Let's close this out on a Tal story, and it doesn't even have to be like a competitive hackathon. It could have been a weekend hackathon at your house. Like, what's something you've done in a hackathon style where it's like that short window of time where you just get something done? Like, what's something that you want to share with everyone?
It's a hackathon that I didn't even plan on going, and a good friend of mine called me, and Dan Schechter, one of the greatest developers alive, and he called me in the morning and asked and told me, Tal, we're going to create what we talked about. Basically, it was a Wii drums, and someone already hacked it, but the hack wasn't complete enough. You couldn't use the two sticks. So a big portion of the hackathon was trying to hack it in a different way, that you could actually reuse the Wiimote without the Wii itself, just with the laptop. And so that was the end of the first day. And the second way, we just build a drum machine using that. And I think it was one of the first, because it was the first application that used both of the Wiimotes. I think it was also the first Wii drum implementation out there. So that was cool. And I almost didn't go to that hackathon. So great, thanks.
I see a pattern here. You're really good at extending functionality of things that already exist. Even if you got
to going through walls, I'm good at that. Yeah,
that's awesome. So I guess sign up for the DAPP Network Hackathon. You can sign up at dappnetwork.hackerearth.com. The sign up information's in the description below, along with some other resources to learn about DSP services. There's also information on the hackathon page. I encourage everyone to sign up early. We want to kind of be able to plan for this. We want to start the mentorship early. We want to start rolling out emails and education material, because like Tal said, you want to be prepared for this. And we're going to communicate to our general channels as well, but we'll also be doing like direct messaging. We have a Slack group set up for the hackathon. We want everyone to get started as soon as possible. So if you're watching this, you haven't signed up yet, head on over to dappnetwork.hackerearth.com. So that's my call to action. Do you have anything you want to tell anyone before we hop off?
No, I think we covered everything.
All right. So you know how we do the closing ceremony here, right?
Mm-hmm.
We've done this before. Why don't you kick it off? Why don't you kick it off, Tal? Until next time, I'm Tal.
Until next time, I'm Tal Muskal.
And I'm Zach Gall. And this
is Everything
EOS. Go EOS and go DAPP Network. Join the damn hackathon.
Thank you.